Hello students, a very warm welcome to this awesome session. So in this session we are going to do a couple of things. One is we are going to have a quiz, and other is we are going to get introduced to a very interesting topic, and that is going to be like Coulomb's law. We'll understand basically how did really Coulomb come to the conclusion, what kind of experiment did he conduct, and not only that, what is this Coulomb's law. Okay, people often talk about Coulomb's law, and are we really going through the right kind of Coulomb's law expression, etc. We'll understand in this session. It's going to be a super interesting session. Initially we will have an awesome quiz on Unacademy learning app on capacitors, which is going to be coming with a lot of PYQs, so be sure to attend it if you're attending the session. Hi Rohit. Yes, Rohit, your code is over here, 896821, and students are very warm welcome to this awesome session. And I hope Rohit, you know how to get onto this quiz. And guys, I'll shortly give you a brief how to get onto this quiz. And before that, a really warm welcome to this awesome session on JEE English by Unacademy, which is India's leading and largest test preparation platform. And guys, Unacademy is impacting near about 7 million lives a day. And be sure that you share this video, you share this channel so that you can spread the impact. And do remember, JEE English is a free of cost initiative where you get all your lectures for your JEE preparation from basics until advanced. So do share this channel, do click on that like button, do not forget to do that. And guys, soon we'll be having many more awesome sessions for you. Not only that, you know what, this is one of those places where you not only get access to just JEE lectures, but also to many awesome strategy sessions. That's the beauty of JEE English. And we have the best lecturers on this channel who are taking you from the basics until advanced. And guys, don't limit your challenges but challenge your limits. Yes, we are going to get started with quiz. We already have 2 participants, so join the quiz quickly students, and the code is going to be 896821 guys. So quickly join the quiz. It's going to be a super interesting awesome quiz. And remember guys, this quiz is meant for you. It comes with a lot of PYQs and the kind of model problems that you need for your JEE Mains and JEE Advanced preparation. And students who know me well and good, if not, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top ranking American university. And I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience preparing and tutoring students for IIT JEE, and I filed patent applications in India and abroad. And that being said guys, how do you attend this quiz? You need to download an Unacademy learning app. If you don't have one, do download it to attend the quiz. And don't forget to stay on the lecture after the quiz, because it's going to be a super interesting lecture as well. So do stay tuned, and it's going to be interesting and insightful, so make sure you attend the complete lecture. It's very important guys, because these concepts are like basics, but the basics is what is required to really solve the problem. So first of all, to attend the quiz, you need to download an Unacademy learning app. If you don't have one, do download it from your Google Play Store, App Store. All you need to do is just type in Unacademy on the search bar, and you'll be able to find us as the first search result, which is the most downloaded education app. And post that, once clicking on that link, you'll click on the install button. If you don't have one, this is the process guys. If you have one, all you need to do is type in the code 896821. Quickly get onto the quiz. We'll get started with the quiz shortly. It's going to be a short quiz anyway. And that being said guys, the next thing would be like, once you download it, you will have to log in, and post that you will be clicking on this plus button. And this is a free of cost feature. It's not a part of any paid subscription, etc. It's a free of cost feature. It's meant for you. And I believe today is also quiz day. Many of you must be attending quiz, so do download it and do click onto this extension bar and click onto this plus, so that you can attend the quiz. And then you will click on to the test, which is the middle tab available on the bottom. And you'll see 5 things. One is going to be home, syllabus, test, and browse and updates. And post that, you will click on the join quiz button. And once you click on to this join quiz button, this thing will pop up, and here you will have to enter the quiz ID, which is going to be 896821. That's it. So the code is guys, the quiz code is going to be, or the quiz ID is going to be 896821. Be sure to get onto the quiz quickly, because it's going to be a super interesting quiz. And yes, and very much related to electrostatics guys, so don't miss out this quiz. It's going to be super interesting. You'll have 80 seconds for a question. I get that, but get your pen and paper. Do share the video. Call your friends on board to attend the quiz as well as to attend this lecture, because this is going to be a super interesting lecture, guys. And do share this on the social media. Do share it on your WhatsApp. Do share it on your Telegram group, or do share it on your Facebook. More importantly, so that students come to know such awesome sessions are happening on JEE English and Unacademy JEE English. So do make sure you share it. And guys. We'll wait for another 2 to 3 minutes and get started with the quiz. We anyway have 2 participants who can attend the quiz, and rest of you, if you're attending the quiz, make sure you're still solving it, and try to potentially attend the quiz on the app. That would give you the feel of the quiz, exam, etc. So that is the entire motto of this quiz. So make sure you're attending it. It's going to be super interesting, guys, and yeah, and lot of PYQs, and make sure you attend it with all your heart, and you're preparing for it. And we have already covered capacitors, so do attend capacitors lectures as well. And it's a very interesting and a practical topic, guys. There is no saying that it's not at all interesting. No one can say that. Capacitor is very interesting. And once after electrostatics, you will see that capacitor is even more interesting. You can expect and PYQs were from the board domain, generally from the current electricity side, mostly from the current electricity side, but also individual capacitor questions are also generally asked. What do I mean by individual capacitor questions is like, how do you calculate a capacitance of a given configuration, etc. And yeah, that is actually a very interesting topic. Alright students, we have 2 more minutes and we'll get started with the quiz, and you can quickly get onto the quiz, or ask your friends as well to get onto the quiz, and keep assessing what is going wrong. And if you understood the concept, that is fine. We'll be also discussing the solution. But if you haven't understood the concepts, try to note down, try to note what is going wrong and what could have been done. There must be an approach, right? The approach must be correct, okay? Next comes timing. First is the approach and the concept, next comes the timing, and of course timing is as important as your concepts, but that is the next stage. But in this thing, yeah, you get to test both of it. Your timing, a little bit less time, but yes, that is that kind of tests your how you do it within 80 seconds. Is there any way, how can you attend any given question? And practically speaking, you have 2 minutes in your JEE Mains for each question, but 2 minutes, read the question, and it's not going to be like an app-based thing, so it's going to take a little bit longer. I think 80 seconds is what would be required, and I think this is going to be a super interesting quiz. We have 1 more minute, and we'll get started, students. And do not forget to stay tuned until the end. It's going to be a super interesting lecture. I promise you, it's going to be super interesting, guys. With all the history, with all the theory, with all the how did it all happen. That is the most important thing and the interesting thing, and post that you'll be easily able to understand it. There's nothing complicated in the concept. All right, guys, I believe we'll get started with the quiz then. So 30 questions, 80 seconds per question, so it's going to be interesting, I guess, and you'll have hints for each of the question. Alright, and there you go. Your question number 1 has come. A really interesting one. So there are 2 plates. Think about it carefully. It's a conceptual question, guys. It's literally a conceptual question. There is nothing to think very hard on this. I believe the option should be like epsilon naught A, epsilon A1 plus A2 divided by 2D. Epsilon A2 divided by D, epsilon under root A1 A2 divided by D, epsilon A1 divided by D. And yes, A1 A2 has a larger area than A1, that means A2 has a larger area than A1, that means A1 has a smaller area than A2. So I think this is a very interesting question. We discussed this concept in our lecture series, so do check it out, and it's very interesting, guys. And I think this is a good question. This is just testing your basic conceptual ability. If you can answer this question, you understood how the capacitors work in a way. Okay, basically think about it. Think about the electric fields how they would be doing, and how is the energy stored, where all would be the energy stored, and do you think area A2 would have an impact or A1 would have an impact? I think just it's about A1. The option is D. Yes, in this case what happened was you have two capacitors, and one of the capacitors had a lesser area, and that lesser area capacitor is what matters, because between that area only all the charges, all the field is going to flow, and the energy would be stored in the form of this electric fields in terms of charge polarization. So that is where, you know, all the energy is going to be stored. So it does not matter even if A2 is larger than if one of the areas is larger than the other one. Alright, again I think this is a very interesting question, and this is a circuit based question. Yeah, typically two kinds of question. The first one would be like, you know, basic capacitor built out questions, where, you know, you're building some, like, you know, you're building some imaginary capacitors, and the other one is you're again throwing into this capacitor into a circuit, you know, like electrical circuit, and then now you would be analyzing the things. So yes, think about it. This is quite interesting. So in the circuit shown in the adjacent figure, the batteries are ideal, so no internal resistance. The charge in the capacitor C is, okay, what should be the charge of the capacitor C? If you remember, we have done similar problems, not the same one, but yes, I think it is a little bit different. Yeah. So think about it. I think you need to do a nodal analysis in this case. So that would be the part, I guess. So yeah, try to, you know, think about it carefully. And yes, guys, it's going to be 0. Check it out. Check out this you know, lecture on current electricity. We'll discuss this concept. So yeah. All right. So if charge of 10 microcoulomb and minus 2 microcoulomb are given to the two plates of a capacitor which are connected across a battery of 12 volts, find the capacitance of the. Okay. So two different charges are given, and now you need to find the capacitance of the capacitor. So what matters? The charge on the inner side, right? Energy is stored only on the inner side. So think about it carefully. It's a very easy question, yeah. Yes, guys. These questions are like, you know, only less than 80 seconds thing. So you can do it, and it's easy, guys. So make sure you're doing it, attending it. It's easy. It's really easy. And think about it. I think this involves charge distribution. And now think about what is the charge that is going to be stored. And I have 10 microcoulomb minus 2 microcoulomb given to two plates capacitor which are connected across a battery of 12 volts. Then find the capacitance of the capacitor. So it should be Q is equal to CV. Alright, answer should have been B. It was, I think, 0.5. Hi Ananya, hi. Absolutely. We'll do that. Yes, the separation between the plates of a charged. I think this might have been a multiple correct answer question. I think this is a multiple correct answer PYQ. So any options are given to you, and generally these kind of questions you can simply. This is a conceptual question, guys. So you need to know what is happening, and the separation between the plates of a charged plate capacitor is increased. Then which of the following will be increased? Okay, charge on the capacitor. So one thing is it's nothing is stated. It's not connected to a battery, so it's isolated capacitor. If it was connected to the battery, the case is totally different. And the other thing is the potential difference across the capacitor. What do you think? So if you are going to increase the distance, what is going to happen to the capacitance? And post that, what will happen to the potential difference? So that sort of gives you a hint. And post that. And in this question, there is also another twist. If it's not mentioned and isolated, maybe both. Maybe you can go wrong, but typically it's an isolated capacitor case, I believe. So yes, it was an isolated capacitor case. Right. All right, guys. I think yes, we can move forward. Yeah, absolutely. We'll do it after electrostatics and magnetism, Ananya. Don't worry about it. Next thing would be modern physics, and then. So anyway, Ananya, do cover also units, dimensions, and vectors. We have already completed it on Unacademy Learning app and YouTube. So different kind of model problems were done on Academy Learning app, special classes, which is free of cost classes. The reason I'm telling you this is because it carries a lot of weightage. It's quite easy. It's the easiest topic and it carries a good amount of weightage. Okay, basic physics topics you can easily score without putting in much efforts. Like 12% of your JEE advanced paper. I don't exactly remember, anywhere between 8 and 12%. And also like 12 to 15% of your JEE Mains paper. That is quite a good amount of score that you can get the capacitor. I mean in your exam. And also current and electricity is something very easy, conceptual, not really tough questions if you understand the concept. Okay, yeah, we'll do modern physics. That's also an easy topic and a very important topic for your JEE Mains. And there are n capacitors and parallel connected to us. What would happen to the energy stored? What would happen to the capacitance? N into C. So it's going to be half of NCV square. It should have been B. Okay, the capacitance has become n times. They are in parallel, guys. Do remember, if in parallel, what typically happens, same amount of voltage would appear across the plates of the capacitor, and n times that energy will be stored. And one capacitor is going to be half CV square, and n capacitors it's going to be n by 2 CV square. Yes, Ananya, that was an important thing, guys. Like, cover the easy topics first. Given the vastness of the syllabus, move very strategically. If you're a 2021 aspirant, move very strategically. Okay, think about the things, how it's going to impact your exam. And given the current situation, it is very important that you don't get distracted, but move very strategically. Staying at home is not easy, but at the same time, you have an academy, you can keep learning. And also, that being said, be sincere to the classes. Electrostatics, if you're attending, maintain completeness. That is one of the most important things. You know what? You attend half the lecture series, forget something. For an example, it could have been in JEE Mains. There could have been a twist, or even JEE Advanced. Many times you get simple questions. There could be a twist, multiple correct. Charge quantization, simple concept. You miss it out. You don't know in the exam. It becomes a mess. All right, it's a simple concept. So capacitance in how do you do this? It's 4 pi epsilon naught r, and you can derive it as well. And anyway, it's going to be 4 pi epsilon naught by r. You can think about it as 1 by 4 pi epsilon naught r is going to be 1 by 4 pi epsilon naught's value, and work it out the reverse way. Okay. Alright, guys, I think we are on good, Rohit. Really good, really amazing. And the work done in placing a charge of 8 into 10 to the power minus 18 Coulomb on a condenser. So condenser is nothing but capacitor. So another term used for capacitors don't get like sort of into an anxiety, or don't get nervous whenever you see condenser. Condenser is nothing but a capacitor. So this is just a terminology, and similarly to also cover the terminologies in every single class and be given the questions that will help you in your exam. So the work done placing a charge of 8 into 10 to the power minus 18 Coulomb on a condenser of capacity 100 microfarads. But anyway, the capacity 100 microfarads would give you the hint. But anyway, students, this is an important tip. This is something that we used to do at least I used to do in my exams. Whenever I see a new term, I used to get into, I used to get nervous. Used to get into anxiety, thinking whether I'm doing it correct. Don't do that. If you understood what is being asked, energy stored, capacitor is simply given to you, and work done is being asked. Simply do it. It's Q into V. It's not half CV square. Do remember 2 times the energy stored. So that is one of the things. But anyway, you could have calculated using Q into V or just CV square. That is an important thing. Really good, Ambika. Really good, Rohit. Really amazing job, guys. And that is going really good. And yes, that is very important. Again, the same question, I think. Right now, everyone knows the answer, I guess. I think So it's 100 microfarads. And one more important thing, if you're getting nervous in your exam around, the number of zeros, simply raise it to the power, not just, in small things. It'll make your calculation simple. And sometimes you can use, for complicated calculation, sometimes you'll feel, 99 into 99, but it is actually simple. 99 into 99 is not that complicated if you do it as 100 minus 1 whole square. Right, 99 square is what? 100 minus 1 whole square. Simple ways to do it, so that you can implement such things, and your exam will be super easy. Exam, or even it's basically 100 square plus 1 square minus 2 into 1 into 100, so 200. Sorry, it's minus 200. So that way you could have easily done some things in exams, or even while doing it. Make this habit, even during your test series and quizzes. That will help you a lot. Try to simplify things. Sometimes maybe it's not necessary to always find the end product, or like the end result after division, etc. You can just simply keep it that way, and you could do it. Good Mahendran, good, awesome, really good. Simple tips, guys, and do share this video, do share the tips with your friends as well, and that is very important. And I think this is a good question and a very easy question. I think there are two ways to do this question. One is you can go by the typical way. There are three capacitors, each of 1 microfarad, and they are connected as shown. The charge on the capacitor C is how much? Okay, all of them are 1 microfarads. How does it matter? What is C? What is A? What is B? So simply parallel combination 2, and then rest. Just apply the loop law to understand what is the drop of the potential. Once you understood what is the drop of the potential, again go back to the combination. This is just an hint. You can do your own way, however you want to do, but this is going to be the one that you want to apply to solve it within 80 seconds or 2 minutes. Alright, if you do it, this is going to be 2 microfarads, and this is going to be 6 volts. You can do the loop law, etc., etc. So it's going to be this way around, I guess. So it's going to be 18 volts to 6 volts. That way, it will be only 12 volts that will be on A and B, that will drop on A and B. It will drop according to the capacitances, but in the inverse ratio. The inverse ratio to 1, you can do the entire math. That is going to be 4 volts. So 4 volts is going to be the potential across this point. Okay. So I think it's just 4 microcoulombs. But anyway, this is the way you want to go about in your exam, and that is going to make it easy, guys. Really easy. Okay. Yes, I think this was an easy question. Let's move on to the next question. I think this is super, bro. Really good. Ambika, really good. Mahendran, really good. That's amazing, guys. Yeah, and one more thing, graph-based questions. Sometimes we miss this out. I think I've covered maybe 1 or 2 graph-based questions, but yes, graph-based questions is also something that you can expect. And if you are good with the basic concepts, the graph-based questions are easy. And carefully notice the x and the y-axis. They can be inverted, and probably you're missing something. For an example, it could be about, I'm just talking about current electricity case, where it could be about conductances rather than resistances. So you want to analyze small things like that. And guys, do attend this question. It's a simple one. Current versus time and voltage versus time graphs are given to you. Of a circuit element is given to you as shown in the figure. Okay, this is not the way that I was thinking, but anyway, so current is flowing initially until that 4th second, and the voltage is linearly increasing with time. I mean, current is constant and voltage is linearly increasing with time. So I think it should be a resistance, yeah, is equal to IR. Alright, I think that was an easy question. Probably in capacitor you do not have a graph. I was just a little confused with it came from the capacitor. So yeah, so it should be a resistance. Anyway, yeah, we have done similar questions, guys, so do check it out. And how do you work around typically these kind of questions? So somewhere the potentials are equated, somewhere you need to find out the capacitances, and find out whether these are in parallel or series combination. any such kind of questions, wherever you find it, you have to follow this typical method, that you'll draw the equivalent circuits and then move about it. It's a simple one, guys. It's a simple one. So A, B, C, D are conducting plates, each of area A, and any two consecutive plates separated by distance T. The net energy stored in them. Initially, you'll take between A and B the capacitance as C, and you will analyze B and C. It's again C, C and D again C, D and E it's C, and E and F it's a C. Just an N. You may want to do it on your own. And A and B and B and C are connected in series, of course. And then comes the connection between this A B C combination and C D E combination. Think about it carefully. They are probably the same potential is appearing across C and E. Good, guys. Really good. Really good. I think it was a near miss, so that is totally fine. Really amazing. Really amazing. So yes, really good question, I guess. So this is a capacity of an isolated sphere is being asked, and it's increased n times, and it is enclosed by an Earth concentric sphere. Earth concentric sphere, inside or outside? Okay, so the thing is, there is a capacitor, spherical capacitor. So now initially you have an isolated capacitor. Then what you're doing is, I think you remember what to do. Okay, it's also an Earth concentric sphere. I think it is Earth probably inside. You can just take it as inside and then do it. If not, it would be outside. Okay. Outside it's simple. So these two capacitors, you have to find out whether they are in parallel or series and move about it. So what is happening is you have an isolated spherical capacitor, and on that isolated spherical capacitor you are adding a concentric sphere, Earth concentric sphere, and it became n times. Now the total capacitance of the arrangement is n times. So what should be the ratio of the radiuses? So yes, you need to do the math, guys. Good, amazing, really good. Really amazing. It's pretty awesome, guys. Really good, Mahindran. Really good, Rohit. Really good, Ambika. Really good. Pretty amazing, guys. All right. So this is a good question, right? So what happens when you insert a conducting plate in between? Think about it. Like a very thin conducting plate. The two plates are shortened. Okay, a thin conducting plate is inserted halfway between the plates of a capacitor of capacitance. Let me read the question then. A thin conducting plate is inserted in halfway between the plates of a parallel plate capacitors of capacitance C. What does the value of capacitance if both plates are shortened? So I think there is a thin conducting plate inserted in the halfway between the plates of a parallel plate capacitor of capacitance C. What does the value of capacitance if both the plate of the capacitors are shortened? Okay. Have been OC. We'll check out the solution. I don't understand the question, I guess. Alright, guys, next question, and yeah. So now I guess it's charging, discharging, and a good conceptual question. So read the options very carefully. So there are two capacitors C1 and C2, and they are charged with Q1 and Q2 and are connected in series with an uncharged capacitor. Alright. Now the thing is, current would flow, right? initially current would flow. They think about they're connected to the same polarities, but still the current would flow. Okay, that thing is not going to change. So C gets charged in any condition, and C gets charged in any condition may not be true. Okay, think about it carefully. Think about it carefully. Will the C get charged in any condition? Okay, and then C gets charged only if Q1 C2 is greater than Q2 C1, and C gets charged only when Q2 C1 is. I think it's an easy question, guys. It's a really easy question. Think about it carefully and move about it. It should have been T, right? Capacitor need not get charged in any of the conditions, and in one of the conditions where the potential is balanced, there is no point of getting charged. It will come to zero. Everything will come to zero. And in the other case, what will happen? It's not necessary one of only Q1 C2 has to be greater than Q2 C1, or the other way around. It is just they should not be equal. The potential should not be balanced. Hence, the current would flow. It was a simple question, I guess. It was only a conceptual question, right? So, all right. I think a very interesting question again. A capacitor stores 50 microcoulomb charge when connected across a battery. When the gap between the plates is filled with dielectric, a charge of 100 microcoulombs flows through the battery, and standard thumb of rule is like 100 microcoulomb flows through the battery, right? So think about it carefully, and if you remember, I think there was a JEE Advanced or JEE Mains question where we did it. So 100 micro, or I don't remember whether it was a model problem, etc. But a charge of 100 microcoulombs flows through the battery. Okay. Now, so it's an easy question though, but there is one mistake that you could do anyway. Last few seconds, so it should be 150 microcoulomb at the end, right? It's not just 100 microcoulomb. 100 microcoulomb is flowing. There was, yes, most of you must have taken just 100 microcoulomb. So it was 150 microcoulomb, guys. Not just 100 microcoulomb. Notice the question carefully. Okay, initially it had 50 microcoulomb, and then 100 microcoulomb flowed into the. Capacitance is increased. Voltage remains constant. Charge would be Q into CV. So it is going to be K into Q into CV. 150 microcoulombs has flowed into it. Total final charge is not 100 microcoulombs has flowed into the capacitor, and that means 150. You can take the ratio and simply get the value of K. All right. So it should be 150 by 100 by 50. Okay. So the given figure, the work done by the battery after the switch S is closed. That's a good question. Earth, what does Earth do? So it's positive work or it's negative work? I think there will be two negative work. This thing. Once you close it, it's going to do a positive work. All right. All right, guys, and I think we are on the last few questions of this full-fledged quiz. The capacitor without dielectric is discharging through a resistor, and at an instant a dielectric is inserted between the plates. Okay, it is discharging to a resistor. That means it is there's no battery in it. It's an isolated capacitor case. Kind of an isolated capacitor case. Try to understand it. There is no way that you are impacting the charge on it, right? And now the dielectric is being inserted between the plates. So what happens once the dielectric is inserted between the plates? Think about it, because I think if that is told, the answer is told as well. Just after the insertion of dielectric, current will increase. Just after the insertion of dielectric, charge on the capacitor will increase. Just after the insertion of the dielectric, energy stored in the capacitor will increase. After the insertion of dielectric, the time constant will increase. What it should be, what has changed? Think about it carefully. There are two things that have changed, right? One thing that hasn't changed, think about it. In the initial condition itself, you have inserted the dielectric. Of course, it's D. It's D, guys. RC has changed. C has changed. It has become K times C if the dielectric constant is K. Okay. So, obviously, okay, one thing you might be thinking is, why didn't the current increase? Current wouldn't increase. Right? dq by dt. And once you differentiate that expression, you will get something like q by so it would be q v would decrease since c has increased, so hence the current would decrease. Charge does not change. It's an isolated capacitor case, and energy stored did not increase, it decreased. Yes, time constant as increased. Interesting question, right? Read the question carefully. Many times that increase will be just thrown into a question, then you would have to notice what should be done there. So the equivalent capacitance of the combination across the given nodes. The arrow indicates across the given nodes. I guess this is simple, guys. I mean, you don't have to put in much efforts. So yes, I think you can do it very quickly. Very quickly, guys. Very quickly is what. So 10 and 6 in parallel is 16, and 16 and 4 in series. 1 by 16 plus 1 by 4 is equal to 1 by C. So that should be 16 by 5. I mean, C 1 by C is going to be 5 by 16. C should be 16 by 5. Right? Yeah. All right. Yeah, and you can expect questions around these kind of concepts as well. This is one of the most asked, concepts. I mean, direct questions is something that you may not want to expect in your JEE Mains or JEE Advanced. Just simply asking you what is the capacitance, etc., etc. Of course, very good questions on this quiz. Really amazing questions, guys. This would literally get you prepared for your exam. 80 seconds, little less, but anyway, this would. I mean, all of these questions are like, most of them are conceptual. No, there wasn't any intensive calculations involved in them. They were mostly, all of them were conceptual, and you could have quickly done it. Most of the questions. I'm not saying every single question is conceptual. Maybe there were only 2 or 3 questions that were in conceptual, right? You could have quickly done it, and the numbers are very easy to play around. So half is filled with 4, and the other half is filled with 6, I guess. So it was initially 1 microfarad capacitor, which is filled with 2 dielectrics of dielectric constant 4 and 6. Now, what is the new capacitor? Simple, guys. Divided into half, areas become half. They are in parallel. Add them. So it should be 2 plus 3, 5. It should have been B, guys, not 10. So area is halved. So I think most of you have just answered, you added 6 and 4 into 1. 6 and 4 is fine. You added them both. That is correct. They are in parallel. Absolutely correct. Divided by 2. Right? Area has been halved. Alright, let's get into the next question then. The 2 spherical shells are at large separation. One of them has a radius of 10 centimeter and has a charge of 1.25 microcoulomb. I think this will involve some calculation, but I think there is some hint given in the options if you notice it carefully. Alright, and also do this. I mean, nowadays JEE Advanced is becoming more and more subjective, but anyway, JEE Mains is still, super objective, MCQ, single correct. So get into the habit of also analyzing the options. Anyway, you have to first of all, clear JEE Mains, and it is the best, exams, one of the best exams. Of course, JEE Advanced is going to be a little bit more advanced. At the same time, you can't predict JEE Advanced paper, so that way JEE Mains paper helps you really well. So try to analyze the options. So yeah, 2 spherical shells are at a large distance, are at large separation. One of them has a radius 10 centimeters and so and so charge and the other one is 20 centimeters. If they are connected by a conducting wire of negligible capacitance, then what happens, guys? So that is I think you need to first of all calculate the capacitance, and you will be equating. Good, really good, really good, guys, really good. Amazing, boy, really amazing. All right, we did this question. You need to do the calculation, but not too much calculation, right? It's a simple one. It's an infinite layer question. So an infinite layer is one of the ways of stating it. Infinite series. So pretty much everything is covered in the single quiz. If you're attending it, at least try to assess your concepts, and most of you are doing it correct, so that I don't think there is an issue. But at the same time, if you're even watching the session, try to solve it. Try to take the note of the hints. Direct answer cannot be given, but you can get the hints and you can do it, guys. So that way you can quickly do it. And keep noticing the mistakes. That small mistakes, notice it, what you have done, patiently observe that mistakes, then don't repeat. That's the key. That is the key, guys. That is literally the key. If you repeat the mistakes, yes, you'll keep repeating it. And especially in the exam, of course you'll do it, because you will be not in a situation to handle the paper patiently. Of course, no one is in the situation to handle the paper patiently. Hence, think patiently right now, so that you don't have to think, you don't have to think about your mistakes during the exam. Perfect it. If you have even 1 year, perfect it. And 2 years, definitely you're going to do it. Guys, you need to solve it, But anyway, I think I'll just give you a short hint. You need to find the repeating unit, and post that repeating unit, you'll be doing the calculation, assuming that is infinite capacitance, repeating unit, calculate the equivalent capacitance, equate it to infinite capacitance. Anyway, you can attend the lecture series. I think we have to still cover Q-based. I think again, good, this is something that has gone wrong. I think the questions that have been going wrong, the majority of the times are repeating, which is also a good thing. So yes, and yeah, anyway, most of you know the answers who are attending the quiz. Let me explain you the concept. It does not matter what is with the A2. A2 is a large area, but there is no going to be fields, or with the fringe fields. So most of the fields are going to be between within this A1 area. It can be like a disk. Okay, it can be a disk, and then the same thing can be asked, right? The same thing can be asked. It can be a disk. The same thing can be asked. Answer remains the same. Does not change. All right. Make sure you understood this point, because it's very important. Like the smaller areas where your fields are going to lie. Even it can be a misalignment. Don't forget, it can be a misalignment. There could be a misalignment, and still the answer would remain same. Don't know what is the small a2. This is given just to confuse you guys. Of course, you'll get options like this. This A2 is totally irrelevant to the question, but you will get an option like this in your exam just to confuse you, and they will say there's a delta A, something, that area difference between both, just to confuse you. Should have been epsilon A1 by D, right? Given that A1 is lesser than A2. Alright, really good students. Amazing score, guys. Really amazing score. Really quick, and yeah. It should be epsilon naught A1 by D. It's a simple one. And students, do share this session, because you're going to get started with a very interesting concept. How did at all Coulomb come to it? Was really the Coulomb the first person to propose Coulomb's law? Or whether even, like pioneers before him, why it was Coulomb who was more successful, and why not maybe someone else also came with a similar theory at the same time, even with more theoretical explanation, and there is a difference. There is a little bit of difference, because there are political things, but there is also like why it worked out. There is a reason for why Coulomb's it worked out. He conducted a very brilliant experiment to prove it in the later point of view, which rest of them did not do it. Okay, so it is very important that you prove the experiment, and that is what has differentiated. Just to give you a short hint, there was another scientist, Henry Cavendish, who proposed the theory at the same time, who wrote the papers, etc. He didn't publish it. And there Coulomb got the name, and the entire name became Coulomb's law, not electrostatic forces. So that is the kind of suspense that is involved in this entire theory. But anyway, all of you know the answer. So just a short story around it. It's a very interesting topic, guys. The very interesting stories. One is AC/DC story that every aspiring electrical engineer or engineer has to read, even for your pastime you have to read it. I think we have discussed this question even earlier. It's a simple one. And the other one is like some such questions like Newton's success and like Newton's photon theory, and how did there was a sign. There was Huygens, I guess, who proposed the wave theory at the same time. Things didn't work out. Later on, it gained so much like acceptance among the scientific community, because things cannot be just justified to particle theory. So these kind of things are very interesting story. They give you a hint even in the direction you have to move, right? Hi HU, hi, and do call your friends, guys, because we are going to get started with a very interesting. I think it is limited to only 32, so I think this is a simple one for you. So apply mathematical equations in these cases. This is not an infinite layer. This is just in 32. 1 by 32 plus 1 by 16 plus 1 by 8. So do the HP. I don't think HP is for infinite. If it's infinite, yes, you could have done it, but I think it's not infinite. And one more thing, students, parallelly cover also some part of mathematics. Don't miss out mathematics. And if you cover mathematics, physics, questions can be solved in JEE Advanced. What I mean is, you'll get a lot of questions that it is going to involve both math and physics. If you noticed, even the previous year paper, there was a simple question. Most of you knew the answer. If you did not know the expression for that mathematical equation, you are missing it. HP series, GP series, and HP series is of course not GP series can be done. At GP you get GP, there is available. GP there is equations available. HP I think there is no equations available. But anyway, like what. Infinite. Okay, it's an infinite number of identical capacitors, guys. Not one, but infinite. So it is a GP series, right? It's a GP series, and you have to find between A and B. So if this is A, this is B. One is going to be 1 by C plus 1 by 2C plus 1 by 3C plus 1 by 4C, so on. Take out the C. Yeah, but an interesting quiz, guys. Today is a quiz day. Today is a special day, hence we have it. But do enjoy it anyway. So it should be A, guys. It's 2 A divided by 1 by R. Take out C common. It should be 1 by C plus 1 by 1 plus 1 by 2. The GP A is going to be 1. A minus 1 by R. A is going to be 1. And R is 1 by 2. So you'd get it as A divided by 1 minus 1 by 2. I hope you understood it. So yeah, do cover things like that. GP series, HP series, we have discussed it during the last JEE Advanced paper. So once check it out, I'll also discuss it before your exams. But do cover those kind of things as well. We'll do basic math, as well. That is very later on. That is very important, more for your JEE Advanced than JEE Mains, because JEE Advanced paper can be more mathematical than JEE Mains. The JEE Mains paper can be pretty straightforward conceptual. JEE Advanced paper. Anyway, this year paper was good conceptual rather than mathematical. Last year paper was heavily mathematical, but expect the JEE Advanced paper to be mathematical. JEE Advanced Physics paper to be mathematical. But good, amazing, Rohit. You're killing the quiz. Okay, you're not attending the quiz. You're attending the quiz, I guess. So yes, what is the capacitance between X and Y is being asked. Draw the equivalent capacitance. It's a simple one, and I think this is a simple one, guys. This is a super simple one. Yeah, it's D. Wheatstone bridge. Wheatstone bridge is also applicable in capacitors. I think we discussed it, and so it is going to be D. 666. When you see a combination like this, RRR or CCC, simply it is going to be good, Rohit. Really good. It is simply going to be that value itself, or whatever it is. You've done this. How do you do this, guys? I've even discussed few hints, right? Even if you have n number of plates, how do you do it? Charge in both these places should be same, but let me read the question. Never jump into the question just like that. In an isolated parallel plate capacitors or a capacitor of capacitance C, the four surfaces have charge. So different charges given to them. Okay, Q1, Q2, Q3, Q4, as shown in the figure. Okay, and the potential difference between the plates is very interesting question, right? So we have done a similar question. Do check it out. So yeah, this is simple, guys. This is really simple. You know one thing. Inside it should be of opposite charges. Outside it should be of equal charges. And charges should be conserved. You can either move by Gauss law as well. One of the things is move by Gauss law. Good, guys. So Q2 minus Q1 by 2 into Q2 minus Q3 divided by 2C. Yeah. Good. Amazing. You're killing it. Yeah. Yes, it is going to be Q2 minus Q3 divided by 2C. Alright, I think the quiz is coming to an end, guys. So yes, last few questions, try to attend them. And in a parallel plate capacitor, the region between the plates is filled by a dielectric slab. The capacitor is connected to a cell and the slab is taken out. In a parallel plate capacitor, the region, I think already someone has answered it, Rohit has answered it in the comment. In a parallel plate capacitor, the region between the plates is filled by a dielectric slab. The capacitor is connected to a cell and the slab is taken out. Okay, now what happens? Is work done? Is the work done? What happened to the potential? And what happens to the charge? Potential difference does not reduce because it is connected to a cell. Okay, so C is wrong. Work is done. Is charge returned to the cell or is charge drawn from the cell? What happens? Like, potential remains same, capacitance decreased, hence charge will decrease. Right? Charges decrease means some charges given back. Alright, guys, I think second last question. This is going to be super easy, I guess. The charge on a capacitor decreases by eta times in time t. Okay, when it discharges through a circuit with a time constant tau. This is simple, guys. This is simple, right? There is nothing in it. Charge on a capacitor decreases by eta times in time t. Okay, Q has become Q by eta. Just equate Q is equal to Q is equal to Q eta, and it is a discharging circuit. Yeah, it's a discharging circuit. Of course, the charge is reducing. It's a discharging circuit. So Q is equal to Q naught e to the power t by tau. That's just like math. You can do it. It's really simple. So it should be and B. No. Simple one, guys. It's B, guys. It's B. Right? Apply log on the both sides, you'll get minus ln eta, and on the other side you'll have t by tau, and t is nothing but tau into log of eta. I think this is the same question. I think we are going to exit the quiz. Anyway, we have seen the question again. So Amazing guys, brilliant work, amazing. Maybe we'll wait for 70 seconds and have a look at the leaderboard, and that was pretty interesting anyway. But that being said, today is going to be a super interesting session. Don't miss it out. Do share the link. And anyway, I think the quiz was very interesting. Really, extensive quiz, covered every topic. So make sure you attend it. Even if you're watching it later, do try to attempt every single question. Of course, you can just watch the video lecture, but these quizzes are meant for you, and try to attend each and every question, guys. Yeah, this question has repeated 4 times. Yeah, it's an interesting question though, good concept. Yeah. So anyway, we'll get into something really interesting today, and it is going to be a super interesting session, guys. And don't miss out this lecture, because this is a basic lecture. And this is something that you have to understand to work. I mean, a very basic thing. We will not go through all this thing again, during the next session. So attend this session, share the session. It's very important you share the session. It's really important. We are going to get into electrostatics lecture. Very short lecture is what it is going to be. Amazing, guys. Anyway, you understood the concept really well. That was very important. We had this question like quite a few times, so that you understand the concept. It can be also misalignment. So make sure you understood the concept. Really good, Rohit, really good, Ambika, really good, Mahendran, really amazing, guys. I think everything is pretty much clear. One was a GP based question, etc. So you guys are amazing, you killed it. So let's get into the most important part. Why are we today? Just a moment, guys. So yeah, so you're going to get into something really very interesting, and that is going to be an awesome lecture session on electrostatics. We are going to get just started with electrostatic forces, which is nothing but Coulomb's law, which is no different from a Coulomb's law. So that being said, students, do check out our Telegram channel. If you're not yet on our Telegram channel, do check out our Telegram channel. Do get onto our Telegram channel. All you need to do is, first of all, download the Telegram app from your Google Play Store and App Store, and just click on to this link available in the description box below. And guys, you can just type in even JEE English if you already have a Telegram app, to find us on Telegram channel. And this is that one-stop place where you're going to get live updates and timely updates on whatever session is happening on JEE English, or even Unacademy's learning app. If any special classes are being conducted, you'll be posted over there, being conducted by JEE English lectures, and even sometimes other JEE lecturers. You will get an update. So do get onto our Telegram channel. All you need to do is click onto this link. Good question. So one of the students have asked, should I directly get into Resnick Halliday, or should I directly get into Resnick Halliday, or should I read NCERT? See, students, NCERT, the syllabus is even going to be reduced next year. Don't expect that JEE Mains or JEE Advanced. No way in both these exams it is happening. They are basic concepts. Your board syllabus is going to become less intensive, which is a good thing. You have ample amount of time to prepare for JEE Mains and JEE Advanced. Until now, students didn't have that leverage. So NCERT is a good book to do. You have to anyway read it. If you're a CBSE board student, you need to absolutely read NCERT. So there is no way out of it. So do read it. But yeah, Resnick Halliday is very interesting. More important is practice as many questions. Take up some books like H.C. Verma, D.C. Pandey. Resnick Halliday, if you take up, you need to do it completely, guys. Then only the fun is there in the Resnick Halliday. Else there is no fun in Resnick Halliday. I've gone through Resnick Halliday, but that is what I read: Resnick Halliday and D.C. Pandey, and some parts of H.C. Verma. H.C. Verma is little advanced for JEE Mains. I mean, nowadays it is fine, and model problems are also covered in D.C. Pandey. So model problems is what matters. So that way, Resnick Halliday is quite interesting, but given that you go through the book entirely, pretty amazing book. But yeah, you can directly get into Resnick Halliday. So the answer to your question is yes. And students, that being said, we covered the entire units and dimensions from 19th September to 22nd of September. And one more important thing, students, day before yesterday, that is on Sunday, we had a special session on units dimensions on Unacademy Learning app from the same time, 11 to 2. If you haven't attended, go and attend that session as well. So I think around 40-50 questions were discussed in that session, and every single model problem, I tried covering every single model problem. I think with that we have ended units, dimensions and measurements. So if you want to completely cover units, dimension, measurements, go on and attend it on Unacademy Learning app. and do check it out, guys. First of all, you need to download Unacademy Learning app. Why? Units, dimensions, and measurements. And this time, 2021 aspirants, a very important thing to do. Anyway, 2022 aspirants is the first topic probably you're dealing with. Either it is kinematics or this. But 2021 aspirants, do remember this is the easiest thing that you can do and score very easily. Do cover this topic. Don't forget to cover this topic. And we have discussed quite a few PYQs. I think we have covered almost all the PYQs, both JEE Mains and JEE Advanced PYQs. So do cover this session. Not only those 4 sessions, as well as the session that was conducted on Sunday. And guys, it's a free of cost special class. So do attend it, and it's on Unacademy Learning app if you haven't noticed it. And you need to first of all download Unacademy Learning app. If you don't have one, do download it from your Google Play Store and App Store. Just click on this install button, and you will get access to such awesome special free of cost sessions for your JEE Mains and JEE Advanced preparation. Yeah, you can do your JEE. Of course, you have to do it right. For your NCRT, you have to do your. I think you have to do. I wasn't from the NCRT. I mean CBSE in 11th and 12th. So yeah, you would have to anyway do your NCRT, guys. So yes, that being said, do click on the install button. Do not forget to do that. And this is how you will get live instant updates on whatever sessions are happening on Unacademy Learning app. And that is a very interesting feature. And you can have amazing features like the quiz that you gave today. So to give the quiz, etc., you need to download Unacademy Learning app. So do not forget to download Unacademy Learning app if you don't have one. Do it, guys. And that being said, if you're looking for a champions tool for your JEE Mains and JEE Advanced preparation, we have one for you. And this is something you can have. This is the best thing that you can have. Not something, but the best thing that you can have for your JEE Mains and JEE Advanced preparation. It's a champions tool that gives you everything that you need for your JEE Mains preparation. So what is this champions tool? Yes, this is an Unacademy subscription, and this comes with everything that you need for your JEE Mains and JEE Advanced preparation. What do I mean by this? I'm saying this again and again. What does this mean is you undergo a structured program, you get access to live quizzes and test series, and the beauty is you get to learn from the best educators across the nation. Yes, you need these things for your JEE Mains and JEE Advanced preparation to be a champion in JEE Mains and JEE. That is what you get on this platform. And more importantly, guys, this is equipped with the best in class technology for your JEE Mains and JEE Advanced preparation. It gives you the feel of JEE Mains and JEE Advanced. And how do you avail this? Yes, the best educators across the nation are available on this platform, and you can get your doubts cleared from them. And all you need to do is click on the extension bar and choose plus as the option, and choose IIT JEE as your goal, and you will click on the get subscription. And the beauty is, guys, it's one subscription, unlimited access. So what are you waiting for? And enroll soon. And if you're planning to enroll, because the programs are getting started last week, anywhere around 524 programs, 600 live JEE preparation programs are online. So make sure you attend it. And if you're already on plus, if not, if you're going to purchase the Unacademy subscription, enroll soon, because this is the best time, guys. And that being said, the 24-month subscription is quite reasonable. Anyway, all of the subscriptions are reasonable, but 24-month subscription is super reasonable. It's only going to cost you 2,100 per month, which is near about 70 rupees a day. And guys, you can apply Murli Live coupon to get the best in class discount to get to this price point, to avail the best in class discount, or to get to this price point. And that being said, we also take away the hassle of paying all the fee at once by introducing our paying parts feature for you guys. So you can split your payments into multiple parts by using our paying parts feature. It's an in-house feature by us. We also have no cost EMI, which also takes away the hassle or the burden of paying all the fee at once. So these are the two kind of things that we have for you, and this is specifically for you guys. And we have other things as well, for your JEE Mains and JEE Advanced a subscription, or be it any test preparation subscription. If you're watching and you're also preparing for something else, yeah, we have that, like debit card, credit card, UPI, etc. And that being said, guys, the 12-month subscription is also very reasonable. It's going to cost you less than 2,900 per month. It's only 2,888. And to get to this price point, do not forget to apply Murli Live coupon, and this is how you'll get the best in class discount on your subscription purchase. So make sure you apply it, don't miss it out. So this is for your best discount, so don't miss it out, guys, and don't miss out the coupon at all. That is something that you don't want to do. And that being said, we have 6,000 plus materials for your JEE preparation right now, 600 plus programs going on. And guys, enroll soon. I'm launching a complete course on a detailed and a complete course on optics, which is going to be from basics until advanced. Even if you don't know anything, if you are even a 2022 aspirant, you can attend this class. This is the most important thing that you want to attend, because optics is the future, guys. So do attend it, enroll soon, don't miss it out. It's launching on 9th of October. Don't miss out even a single sessions. They are going to be short sessions. The initial sessions will be for like 1 hour, 1 hour, and 1.5 hour and odd. But it's only 1 hour class. You don't want to even miss out single class, because this is an intensive program. It's going to be a structured program. We'll be going through quizzes, dedicated doubt clearing sessions, and extensive problem sessions. So it's the complete field that you need for your JEE Mains and JEE Advanced preparation, launching on 9th October. Don't miss it out, students, especially on JEE English. And if you already have subscription, don't miss it out. And if you're planning to enroll soon. And do it quickly, guys. And that being said, students, do share this video. Do click on that like button. All your friends on board. We are going to get started with something very important. Do remember, knowledge has the beginning, but it never has an end. But for your JEE Mains and JEE Advanced, you need to know until where you need to study, because you're preparing for an exam. And make sure you keep your dreams alive. And that being said, yes. So a very interesting story before we get into this. Yeah, of course, Charles, Augustin D. Coulomb was the first one to propose Coulomb's law. Of course, it's named after him, etc., blah, 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 blah. But the thing is, in 600 BC and odd, initially, Thales of Miletus has proposed, kind of Coulomb's law. But the issue was he proposed it based on, magnetism. So it's magnetism? No, it's not related to magnetism. Yes, it's not related to magnetism. Hence, it was not very successful. Not until 1700 AD and not, so that was 600 BC, and that is 1700 AD, near about, not 1000, guys, 2000 years. Think about it. Subtract 600 and add that 600 years. Don't subtract 1700 from 600. So near about 2300 years, people didn't know about what is this electrical phenomena. So then, Thomas Brown proposed all this, there is something known as electrical charges, there is something known as electricity, coined the term basically, electricity, etc. Then people started understanding. So that is the importance of coining terms. If you understood, if you have attended, a previous session, if not, you can attend the first lecture. It's a very interesting lecture. It's a little bit old lecture than compared to the rest of the continuous series. So on units, dimensions, and measurements, there was the first lecture in which I explained, why, there is a necessity of units and like standardized units, etc. So that is the way it begins. Something is coined, a term is coined, people start understanding things, and it starts sparking. People started understanding. There were many attempts, not just Charles D. Augustin. Before that, before Charles Augustin D. Coulomb, there were many scientists who proposed it. But at the same time, two people theorized it. One was Coulomb, and the other one is Henry Cavendish. Both made papers, both wrote papers, both wrote theories. Henry Cavendish did not publish it, but whereas Charles Augustin D. Coulomb did publish it in the year 1785. In fact, I think Henry Cavendish theorized it even before Charles Augustin D. Coulomb, sorry. So that way, Charles Augustin published the paper first, hence it was all named after him. Okay, he was not the first one to propose the theory, but he was the first one to scientifically prove it and write papers around them. So there were like three reports of electricity and magnetism, where he proposed Coulomb's law, named after him, of course. And that being said, guys, what did I say? I said that he proved not only through equations and expressions. He just did not publish theoretical paper, but he also hi Ananda, hi, namaste. Yes, guys. And the important thing is, like, he also conducted experiments and proved it. So what he did was he invented a specific instrument for just proving the Coulomb's law. It is known as Coulomb's torsion balance. Torsion balance already existed. Coulomb's torsion balance is a modified version but totally designed for this experiment. So let's understand what is the beauty behind this entire instrument. It's just probably not in a syllabus, but a very interesting thing. Something important to understand. I'll tell you why. Because there were questions earlier in JEE Mains and JEE Advanced, and let's understand what is this first of all. So there would be first of all there would be like two arrangements. One is you'll be seeing a scale. On the scale you'll be reading the deflection. And it would be suspended. There would be a silk thread, etc. In this experiment, it was a silk thread. It can be any thread. It would be suspended, and there would be two balls. One ball would be just a metal ball, and the other one would be a charged. In this case, it was a charged brass ball, I guess. There was a charged brass ball, and there was a suspended charged object. So this is a charged object that is suspended externally. Everything has to be done carefully in this experiment. Understand that point. Even a small mistake, like it is messed up. It's totally messed up. So back in the days, this was the first torsion balance, Coulomb's torsion balance that was designed and that can measure electrostatic forces. This was the first thing to do the electrostatic forces. So there was a charged sphere and there was a charged object, an externally suspended charged object. Why am I saying this? Because you'll understand the reason once you understand the way he conducted the experiment. So once he suspended this external charged object and he brought this external charged object near the sphere, there was a repulsion. Okay, so that means there was a torque. That means there was a force on this charged sphere. On this charged sphere there was a force, and this force created a torque. Okay, this is a hanging one, right? So it created a torque. Cannot move back and what do I mean? Linearly, but rather it can move in a circular motion, and there was a torque. So due to this torque, due to this repulsion, there would be some torque. Why repulsion? As we saw in the earlier session, like charges repel. So in this case, it was like charges and they repelled. And there was some deflection. Using the deflection and using all this k, theta, you can understand what was the torque. So one was a measurable quantity. The degrees is measurable. The force of repulsion is measurable. If the torque is measurable, the force of repulsion is measurable, and then using that you can derive the electrostatic force. Very interesting. A specific instrument, Coulomb's torsion balance, is a specific instrument designed to measure these electrostatic forces. If it would have been unlike charges, sorry guys, it should have been if it is unlike charges, they may get attracted and it wouldn't have been possible back then. So that was the entire interesting thing about Coulomb's torsion balance. A very interesting experiment. A very enthusiastic person who proved everything. He wrote the theory. Henry Cavendish also wrote the theory. He gave up at some point. But Coulomb never gave up on his theory. He proved it until the end. Hence it is named after him. Think about it. The entire thing is named after him. Just like Newton's few laws, it is named after him. Isn't it amazing? So some lessons for you. Some of you are also aspiring researchers, I guess. So to publishing it earlier matters. Someone else publishes before you. It can be a totally novel theory. They gain the credit. Make sure you do it early. Okay, so it's a game of who comes out the first with the theory. This is just one of the examples. I've even discussed a few other examples during our basic lectures around physics, where we discussed what is physics, etc. during our initial lectures. So let's now understand what is this Coulomb's law. Let's get a brief and we'll understand how it all works. So these are also the postulates put forward by Coulomb's, and we know this as well. Now this is obvious to us, but back in the days when charged and current electricity was the term that was coined in 17th. So think about it, guys. Think about it very carefully. Like back in the days, people did not even know about electricity. People did not know about charges. Now it is very obvious to you, right? Like charges ripple, positive will ripple, negative will ripple, and unlike charges attract. But back in the days, it was not obvious. back in the days, it is something very different. It is something that is something very new to people, right? Current and electricity term itself is very new to people. Of course, electrostatics is also very new to people. Electrostatic forces is also very new to people. People weren't thinking in the direction. Now, F is equal to mg is obvious to you, but when Newton proposed it, it was not obvious. So for him, this was not an obvious thing. Hence, it was a postulate saying that yeah, like charges repel and like charges attract. Okay. So and the most important thing he proposed was forces act along the line of charges. So if you observe this F12, which is nothing but, so what happens here is like let's first of all analyze this case. Why like charges repel? That is a question by one of the students, I guess. So like charges repel because they have repulsive forces. So yes guys, now the thing is, so observe this charge applying a force. I mean this charge is applying a force on this Q2 positive charge is applying a force on Q1, which is going to be in the direction of F12, a repulsive force away from Q2. And now similarly, Q1 would also be applying a charge, a force. Q1 charge will also be applying a force on Q2, which is also going to be in repulsive in nature and away from Q1, since both are like charges, right? Even if it was negative Q1 and negative Q2, that is, let's say both are negative charges, even in that case, assuming Q1, Q2 are just positive integers, in that case as well, F12 and F21's direction would be that way. So F21 is the force applied by Q1 on Q2. Okay, just to give you a clarity, F21, this force is applied by Q1 on Q2. Similarly, F12 is the force applied by Q2 on. Now, what about unlike charges? They would attract, and would the force direction be same? No, opposite. Still opposite, right? Now let's analyze this case where you have two like charges. So let's say I have a charge, a positive charge plus Q1 and a negative charge minus Q2. There should be an attractive force. That means the forces should act as if they are moving towards each other. Okay. So for an example, let's say the force on charge Q1 by Q2, which is going to be towards Q2. So this is the force applied by Q2 on Q1. And similarly, F21, if you have noticed, is the F21, which is nothing but the force applied by Q1 on Q2, which is going to be in the attracting directions towards Q1. Okay, and the important thing is there is a line joining them, isn't it? There's a line joining them. If you take a straight line joining them, the line joining these charges is where the force is directed. And even in this case, the force is directed that way. So this is an important postulate, isn't it? And thing is, the force is directly proportional to the magnitude of charges, right? So he also observed that the force, the electrostatic force, if I had increased the magnitude of charge, so in that case it was both like charges, that is repelling. He increased the charge in the torsion balance. Try imagining the torsion balance, and he increased the charge on one of these spheres. The repulsion force was greater, the deflection was greater. So in torsion balance, what you are doing, you're measuring that deflection, the degree deflection. So what happened was he saw that okay, the deflection is high, as increased the magnitude of charge. These are all experimentally proposed, guys. Even though the theory was proposed, he proved the things experimentally. Okay, so electrostatic force might have been a phenomena that you can that is available. Sorry, that was proposed. And in fact, what I meant to say was, these papers might be available online if you search for them. With all the translations, it would be available. So you can go through them. For an example, Maxwell's paper or available. The way it was written by the Maxwell. So generally, it is good to go through the papers, especially during those times. the proposed research were exotic. Exotic means that is the first time people are discovering things, inventing things, coming up with new phenomena. And not even it was people are inventing things. That was not the time for invention. That was time for discoveries, just to learn new scientific theories. Then comes invention, right? First comes theories. So those theories, these scientific phenomena, people are just coming up with them. And that in those times, authors, I mean, they were scientists, and some people were awesome inventors, scientists, etc., 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 artists. For an example, Leonardo da Vinci, etc. I think his name is Leonardo da Vinci. Yeah. But they were generally multi-talented. They had some other profession. So this was a passion that they were doing. This was something that they were doing, not just as a profession, but as a passion. So the way the things were written back in the days are very different. If you read those kind of papers, you'll really get to understand. During Maxwell, he was a professor. I guess he was a professor. He was working in a research institute. But at the same time, he was the first one to understand and propose it. What his professor was saying? What are you doing over here? What is this thing that you're coming up with? So he was like, no, this is the thing. You just didn't understand it. I mean, he was initially, trying to state things very calmly. Then he said that you didn't understand it. This is the thing. This is what is happening. Try to imagine it. Try to observe the things. Try to, kind of grasp the theory. Now it is obvious, right? After a few years, after 100 years, you'll see that students are saying, oh yeah, moving charges create magnet. The force is acting on the moving charges by the magnetic field, etc., etc. These kind of things will be flux is obvious. Change in magnetic flux, yeah, that is true. But now, now it is little bit not obvious because we are not so much exposed to magnetism. We are exposed to magnetism in the later stages, but whereas we are exposed to mechanics, etc., in the earlier classes. So these are very interesting papers to go through. But anyway, now the thing is, he said that the electrostatic forces are proportional to the magnitude of charges, more aptly said product of magnitude of charge. You can substitute Q1 as negative, you will get it, Q2 as negative, and you will get it. Okay, so you can change the signs. And the next thing he observed was there was an inverse relation. Okay, if you observe this graph, this is an inverse relation between force and distance. This tells you that force is inversely proportional to distance square. Okay, so yeah, he found the inverse relation between force and distance, and this was the second thing. First thing is actually the third thing. One is the force is directed along the line of charges or the line joining the charges, and the next one was the force is proportional to the magnitude of charges. You can say Q1 proportional to Q1, proportional to Q2. That is also true. So it is proportional to charges. In our case, we are going to say product of charge. And the force is inversely proportional to the distance. In fact, inversely proportional to the square of distance. Pretty similar to gravitational force. Now, another important thing is force is also dependent upon medium. Right? It is dependent upon medium. What does this mean? It means that if it's a heavy dielectric medium, let's see what happens if it's a heavy dielectric medium. So if it's a heavy dielectric medium, the fields are weaker and the force is also less, right? So there would be polarization typically, etc., etc. I hope you understood that point. If you remember the capacitor lecture, this thing is also clear. We even discussed a problem over there, if you remember. So the force is also proportional to the K, which is not a direct indicator of the permittivity, etc. We'll understand that concept moving forward. So that being said, so these were the postulates put forward. The force is dependent upon magnitude of charges, the medium of interaction where the charges are kept, and the distance between the charges. So the force is nothing but K. He said that force is K into Q1 divided by R square. So these things were something that he found out. So this Q1 Q2 by R square. So and then he proposed, there is a constant. That constant is nothing but Coulomb's constant, and he called it K. Okay, and then comes the some of the things around them. What is K? K is nothing but 1 by 4 pi epsilon. Not necessarily epsilon naught, it can be epsilon as well. So depending upon the medium. So if it's in vacuum, it's going to be epsilon naught. Okay. And what is the value of epsilon naught? 8.85 into 10 to the power minus 12. Guys, something to remember. This can be approximated to 9. So this is something that you have to remember. So K is equal to 1 by 4 pi epsilon naught, 9 into 10 to the power 9 Newton meter per Coulomb square. You don't have to necessarily remember the units. You can derive the units. Not a big deal. But value you have to remember. 9 into 10 to the power 9. Value of K, 1 by 4 pi epsilon naught. And what is the value of epsilon naught? 8.85 into 10 to the power minus 12. I generally have a habit of remembering easier things, which is going to be 9 and 9. If you notice it, this is near about 9, generally written as 9. Even if you remember the capacitor question, it was 9. And this is what? 10 to the power 9. Right? So it's 9 into 10 to the power 9. And that way you can derive if necessary, or else you can remember this as well. It's 8.85 into 10 to the power minus 12. So, but there are some limitations with Coulomb's law. This is an awesome, electrostatic force-based law, but there are some limitations with it. The limitations are, it should be point charges. So this Coulomb's law, this force, this interaction between charges, this electrostatic force is only applicable for point charges or spherical distribution of charge. Okay. So it was proposed for point charges initially, and then came the spherical distribution of charges. The charges should be stationary. I know this is a little theoretical part, but interesting, guys. Actually, this is the interesting part. Problems are very important, but at the same time, it is very important to understand what was happening. How did these things? What are the limitations? Can you apply Coulomb's law? So sometimes, these kind of questions may come in a very indirect manner. So the charges should be stationary. And one more important thing, the distance between the charges, very important thing, the distance between the charges should be very large compared to the point charge. So if at all there is, a symmetrical or non-symmetrical distribution of charges, and then you're trying to calculate the force between, let's say, a disk and a disk, and they are kept at a very large distance, then yes, this is fine. At a large distance, they both act like point charges. But do remember, the distance between the charges should be very large compared to the size of the charges of the point charges. So 3 limitations. One is your charges should be stationary. Other one, it should be point charges or spherical distribution of charges. And it should be, the distance between the charges should be very large compared to the size of the point charges. Good, Rohit, really good. You can keep working on things like this, guys, dimensional formulae, etc. as you go through. And a very good habit, Rohit. Like, whenever you're completing a topic or whenever you're listening even to the lecture, try to write down the dimensional formula. Try to derive it in sometimes, but if you can remember it, try to, write it down. It's a good habit. Remembering units and remembering, dimensional formulae. But anyway, you can do that, but more importantly, try to understand the lecture. That is the most important thing. It's a very interesting lecture. So first of all, let's get into a problem, guys. So positive charge Q1 of 15 micro Coulomb is placed at a distance 2 meters from another positive charge Q2, which is of 6 micro Coulomb. So this is 6. Notice on the picture, and this is 15. And if you remember, both will be attracting. Q1 and Q2 will be attracting Q3. There is a charge Q3, which has to be placed somewhere such that the net electric force on it is 0. Right? Think about just 1D, forget the 2D, we'll get into 2D later. So there is only 1D, one axis, forget every other dimension, only 1D. Now what is being asked is, where should this Q3 be placed such that the net force on it is 0? Any guesses, students? Just by having a look at the options, it is quite possible to guess it. Ask me what. This is a simple question. There's nothing like JEE. I don't know this. I think this was a JEE Mains question or etc. But a little older, I guess. But anyway, this is going to give us a very important insight. So try to guess the answer from the option. There's Q1 and Q2, which are going to attract the charge Q3. So one thing, guys, one really important thing. Alright. Hi Archit. So a very important thing is it cannot be actually this was also supposed to be negative. I wanted to bring out this as negative, I guess. So anyway, it cannot be negative 3.44 or so okay, this is positive. I'm sorry guys, sorry. It cannot be it was 4 meters only. Okay, it cannot be 3.44 meters minus 3.44 meters or 4 meters. The reason being, if it is beyond this 2 meters distance, so the distance between Q1 and Q2 is 2 meters, right? If it is beyond this 2 meters, what would happen? Both will be attracting, so the net force cannot be 0. And similarly, if it is beyond this 2 meters, which is on the negative side, let's say it's less than 0, some negative distance, in this case just talking about axis, it is also not possible, because again there will be a net force. Net force cannot be 0, right? Net force cannot be 0, so it has to be positive values. Okay, it has to be positive values. From the given thing, 4 meters is not possible since this is greater than 2 meters, and this is not possible since this is less than 0, right? On the left and the right side of the charge arrangement, Q2 and Q1, it is not possible. It has to be in the middle. Okay, so these two options can be eliminated conceptually. Now coming to 1.755 and 0.755, is probably 0.755, not just that I did the equation, but if you observe the value of the charges, you can find it from the ratio. And one more important thing, students, same medium is not being told. Hi Sunny, hi. The medium is not being said in this question, so simply what you can do is you can simply write down, so the force of attraction between Q1 and Q2. Okay, sorry, Q1 and Q3. Q1 and Q3 should be equal to the force of attraction between Q2 and Q3, which is going to be Q2 comma Q. Okay, just a function guys, just a function, just for your understanding. So from Coulomb's law, I can write it down as K into Q1 by Q2 divided by R square, etc., isn't it? This would be K into Q1 Q3 divided by in this case, let's say between Q1 and Q3. Okay, let's go by the diagram. Okay, between Q1 and Q3 it's 2 minus x. If this total distance is 2 meters, this is going to 2 minus x. If I say the distance between Q2 and Q3 is just x, whole square should be equal to K into Q2 into Q3 divided by x. Simply what would you do? Cancel out Q3, K, same medium, does not matter. So just cancel out the basic things, right? One is going to be Q3 cancelled out, K cancelled out. Now it is Q1 into x square is equal to Q2 into 2 minus x. So the value of x is asked in the question. Probably things are given to you, but anyway, maybe it's not explicitly mentioned as x, but you could have understood it because it can be even 2 minus of whatever value it is. Now let's get into it. Harshit, hi, didn't get your message. Yeah. So yes, students. So the thing is, now you're going to. This is just a completed version of it. I'll explain you what has been done. Nothing. A quadratic equation will come out. It's going to be Q2 into 2 minus x square and Q1 into x square. If you carry this out, this is Q2 into 2 minus x square and Q1 into x square. And what was the value of Q1 and Q2? Q1 was 15 coulombs and Q2 was 6 coulombs. Okay, Q2 was 6 coulombs and Q1 was 15 coulombs. So you substitute the value just for your understanding. We'll do more problems in the next session. Next session is meant for Coulomb's law, so don't worry. This is just to give you an introduction, a very important part though, very important part. Why I'll tell you, even this problem is very important. Everything is actually conceptual. Just equated the force, wrote down the quadratic equation, you'll get something like 9x square plus 24x minus 24. Of course, you're going to write down, minus b plus minus under root b square minus 4ac divided by 2a to find out the solution. You'll get two solutions. Quadratic equation will give you two solutions, of course. One is going to be minus 3.44 and the other one is going to be 0.75. If you notice the options, I gave you intentionally the minus 3.44 meters. But that is not true. It's only 0.755. We know it conceptually. But what has gone wrong here? If you think about it very, very carefully, something has gone wrong in our entire, the entire way we have described something until now. Okay. Let's understand what is that. Electrostatic force is a vectorial quantity. It's a vector quantity, guys. It's a force. It's a vector quantity. We didn't use the vector. If at all you had understood there is a vector involved in it, you have simply said, all right, this should have been the answer. Even if you didn't know the concept of the like. Anyway, you guys know it. That's a different thing. But as in a very, the best way to represent it, how does the force act, etc., is only defined by vector, right? Because force is a vectorial quantity. So that way, the force should have been written something like, k into q1, q2 divided by r square into some r cap. Why r cap? I'll tell you r cap. I'm going to say this is the distance between them. I'm defining a unit vector r cap along this line. Force is going to be along the line, Coulomb's law. So then you're going to multiply it with a unit vector r cap, right? So the unit vector r cap would give you the direction of force. But as you remember, the force in this case, it's both are positive charges, q1 plus q1 and plus q2, so they will be repulsive in nature. But the thing is, what would be the direction of the force? So let's, in this case, the distance is just r. Let's keep it as r. We'll say, we'll calculate initially the force F21, which is nothing but the force applied by Q1 on Q2, which is going to be K into Q1 Q2 divided by R square into, and that R21 cap, this is nothing but R21 cap, which has to be position vector R2 minus of R1. Isn't it? R2 minus of R1, because it is repulsive in nature, but even if you are negative charge, you can substitute negative. We'll come to that point. So you will basically write down the position vector, which is going to be in this case. Is going to be in this case R2. So I'm just talking about force, F21. It's going to be R2 minus R1 divided by R1 minus R2 or R2 minus R1, mod of R2 minus R1 or R1 minus R2. So that is going to give you a unit vector, right? This is going to give you a unit vector R21. This is nothing but R21 cap. Alright guys, that is it. That is it. Really simple. That is the better form of representing things, and it can be further, like little bit complicated. It can be a little bit complicated in a complicated way, because if you remember, r square is square of magnitude of distance between them, which is of course distance. I mean the shortest distance, of course. So in that case, it has to be positive. So there is a mod over here. You carry this mod, multiply it, which is nothing but r1 minus r2. If you're talking in terms of position vector, it's nothing but r1 minus r2 or r2 minus r1 mod whole cube. Okay. Into, in the denominator you'll keep a cube and you'll write it as r2 minus r1. This is irrelevant, you know how to derive this, but anyway, do derive it. If you don't, if you're totally new, a little bit, maybe here and there, but do write it down and derive it. So that is it. That is all about, Coulomb's law. But do remember, guys, F12 is not equal to F21, since R12 is not equal to R2. The only difference is R12 and R21, right? You notice this part, the only difference is R21 and R12. If it was F12, it would have been R12. Since R12 is not equal to R21, these are vector quantities, F12 is not equal to F21. But rather, if you know, or if you remember, or if you know it, it's R12 is equal to minus R21. Hence, F12 can be written as the one magnitude is the same. Magnitude of the force on Q1 by Q2 is the same as magnitude of the force applied by Q2 on Q1, which is nothing but F12 and F21 will have the same magnitude, but they will have opposite direction. Be it is negative charges or be it is positive charges. So what I mean is, be it is negative positive and positive positive, like or unlike charges. This thing is not going to change. So let's say I have a negative charge minus Q2, right? I have a negative charge minus Q2, and this minus Q, of course the forces in this case, the forces F12 and F12 and F21 both are attractive forces, they are not repulsive forces. But in the earlier case it was repulsive forces, but the force direction is still going to be opposite. And how do you understand it? Simply substitute things, and substitute this time saying that Q2 is a positive number, just substitute minus Q2, assuming this is a negative charge, maybe one this is the negative charge, this is the negative charge in this case, okay? Just substitute it, and then you will get F21 is equal to minus Q2 Q1 divided by R square into K into R21, right? Now the thing is, notice, if you go back to the positive repulsive case, F21 was, what was the value of F21? F21 was Q1 Q2 divided by R square, K into something, K into Q1 Q2 divided by R square into R21. This thing did not change. There was a negative sign, hence the force is in the reverse direction. Right? That is all it was changed. That's it. The minus appear. That's it guys. That is all about Coulomb's law. This is the most apt way to represent force, and hence the Coulomb's law. Good evening, good evening, good evening. Yeah, we'll do that as well. We'll start with EMI and AC current. Yes. So I believe this is about Coulomb's law. I'll take you through more model problems and just brief you through the concepts tomorrow as well. But make sure guys, don't miss out even a single lecture. Hi Broccoli, hi. Don't miss out even a single lecture. It's a very interesting concept. Also a heavyweight topic, so don't miss out even a single lecture on electrostatics or current electricity or capacitors or magnetism. This thing will generally cover 30% of your paper, 30-35% of your paper, lesser time than mechanics, etc. It's an awesome and a very interesting topic to cover. And guys, keep smiling, keep enjoying, keep sharing such awesome lecture series, because they are made for you and it's a free of cost initiative by Unacademy. So make sure you share this video with your friends on social media like WhatsApp, Facebook, Telegram, etc. Wherever you have an like social media account and you can share it, do share it guys, do share it, and especially with your friends, share it, and brainstorm, discuss, understand. It's very important to also get that understanding of the concepts. They'll help you really well. And keep smiling, don't forget to smile. This is the most important thing. And guys, work hard and smart to achieve your success. And and that being said guys, do check out our Telegram channel, and it's available in the description box below. You need to first of all download this Telegram app from Google Play Store and App Store. So download it from the like the App Store or the Google Play Store, and then you need to click onto this link available in the description box below, or just type in JEE_English. You'll be able to find us. And once you get onto this our Telegram channel, you will be able to get timely updates on every lecture series that is happening on JEE English or Unacademy Learning App. Yes, we keep conducting many free special classes on Unacademy Learning App. Yes, we'll start EMI and AC. We'll start EMI and AC, we'll complete EMI, AC, and also your nuclear. These are like something very important to do. But that being said guys, do check out this lecture series. Don't miss out this lecture series on A to Z of units, dimensions and measurements, because it is a very important and an interesting and an easy one, and it will hardly take you 15-20 hours to cover this entire session. It's a complete extensive session. We also discussed many model problems around this on the last Sunday, that means this Sunday which just passed. So do check out the special classes. They are amazing, they're awesome, and they are also free of cost. So you will be attending these kind of special classes, A to Z intensive lectures. We also discuss many more model problems on the Sunday, so do check it out. And we discuss this on Unacademy learning app. You can also attend the lecture series on YouTube, but they are like detailed lecture series and the model problems are different. So do check out Unacademy learning app. This special class on Unacademy learning app. For that, you need to first of all download Unacademy learning app from your Google Play Store and App Store, which is the most downloaded education app across India. Do make sure you download it by just typing in Unacademy in your Google Play Store and App Store. The first search link is going to be Unacademy learning app, and then click on this install button, guys. That's all you need to do, and there you go. You will get also the live timely notifications on such awesome sessions happening on Unacademy learning app. So do not forget to do that. And students, if you are looking for a champions tool for your JEE Mains and JEE Advanced preparation, we have the best champions tool and a preparation program for you, guys. We have the best educators across the nation on our subscription platform, and you get to attend live quizzes, live test series. If you can afford it, it's the best thing to afford for your JEE Mains and JEE Advanced preparation. And not to say, we have the best technology for your JEE Mains and JEE Advanced preparation that gives you the gist of JEE Mains and JEE Advanced preparation. And also, guys, it's a structured program. You'll go through an intensive and extensive structured program, and in that this entire subscription programs, you'll have different programs to enroll in. So you'll be enrolling in different programs according to your needs. For an example, let's say you feel that you haven't covered units, dimensions, and measurements. There would be a plus course on it. You can go and subscribe and attend it and enroll and attend it. It's best to attend it live. That is the most apt way to do it, since this is a structured program where you get dedicated doubt clearing sessions. So for an example, some part of units, dimensions just caught over, like vernier calipers, then everyone gets to ask a doubt on it, and the concept and everything becomes clear around it. And that is the awesomeness of it. And you also have dedicated quizzes. So it's an all-rounder, structured program for your JEE Mains and JEE Advanced preparation. It's a champions tools, guys. So make sure if you want to purchase one soon, enroll soon, because this is the time to get started, especially 2021 and 2022 aspirants. This is the time to get started. All you need to do is click on the extension bar, choose plus as the option, and then you'll choose IIT JEE as your goal, and then choose get subscription. That's it, guys. That's it. You need to do. And the beauty is, it's one subscription, unlimited access. You can attend as many programs, you can enroll to as many programs as you want, and you will get access to the best educators across the nation for your JEE Mains and JEE Advanced preparation. And the price is also reasonable. It's only going to cost you 2,100 per month, and you get to this price point with Murli Live coupon. So do not forget to apply Murli Live coupon to get the best discount on your subscription purchase. So make sure you apply Murli Live coupon. And guys, it's only 70 rupees a day if you think about it. If you divide it by 30, it's pretty reasonable. And that being said, students, we also have convenient payment options for you. You can pay you can split your payments into multiple parts, and it takes away the hassle of paying all the fee at once. This is an in-house feature bias for you guys, so do check it out. We also have no cost EMI, which means no interest on your EMI. So do also if you want to purchase the subscription, and if you don't want to go through the burden of paying all the fee at once, these are some awesome payment methods for you. We also have other traditional payment methods like debit card, credit card, UPI. And that being said, guys, even a 12-month subscription is very affordable and reasonable. It's only going to cost you less than 2,900 per month, which means 2,888 per month. And how do you get to this price point? You need to apply Murli Live coupon. So you apply Murli Live coupon to get the best discount on your subscription purchase. And guys, we have 7,000 plus materials for your JEE preparation. And just this week alone we'll be having 600 plus live programs going on. So they are like live sessions for your JEE Mains and JEE Advanced preparation, dedicated lectures from IITians and from the best lecturers and educators and teachers for JEE across the nation. So enroll soon, and launching on October 9th, optics B2A, which is going to be basics to advanced, a fully complete, I mean like a complete coursework for your optics preparation, be it your mains or advanced. So it's going to be a super interesting course for your JEE mains and JEE advanced preparation. This will be completing both mains, mains and advanced syllabus, of course. Along with that, we are completing both wave and ray optics. So do attend it. It's going to be super interesting, a heavyweight topic, be it you are preparing for JEE mains or JEE advanced. Very interesting. Future is the optics, guys. So make sure you attend it. And that being said, students, take care, stay safe. Take care, stay safe. See you in the next session, and do share the session. Take care, stay safe. Bye bye.